the AI decided that it was going to, rather than make the change requested, the easiest way to accomplish it was to delete and attempt to recreate the production database. And because it was being used by the CEO of the company, it had the permissions to do this. And so they ended up having their entire production database and the backups of that database completely deleted. The disruption to service was immense.
You don't have to look very far to find stories about agents doing weird or unexpected things. But here's the thing, is the context has changed. Agents are now doing real work. They're reading information on databases. They're potentially making payments. They're using credentials and they're touching production systems. The problem is, and if you've read anything about some of the headlines, you've seen that these agents can make some mistakes. The challenge is that these mistakes are quite substantial. If an agent is touching production systems, what you get is agents deleting databases, agents changing cloud environments, potentially exposing sensitive data. Anyway, the real issue is that it's in fact staring us right in the face. Enterprises are starting to deploy these agents, but really they actually can't answer a few really simple questions when something happens. First off, which agent did it and why was it allowed to do it? Answering that question requires more than identity. It requires an in-depth focus on agent authorization. It forces us to answer a relatively simple question. How do we define and enforce what an agent is allowed to do? Well, that's what today's podcast is all about. My name's Eric Broda.
And I'm Davis Broda.
Welcome to the Agentic Mesh podcast. So, Davis, let's get started. I'll just do a quick recap. This is obviously an episode in a series about agent security. Last week, we talked about agent identity. And the whole notion there was that in order to participate in an enterprise, an agent needs to be, just like an employee, needs to have a stable, persistent identifier that we can then attribute capabilities, permissions, roles to. And that will allow, that's the first step in allowing us to understand which agent did what. The second part in the series is today's episode, and that's where we're going to talk about the task-scoped authorization boundary that defines what an agent can do. The next episode is about the execution boundary. How do we actually enforce what that agent is allowed to do? How do we enforce what skills, tools it's actually able to consume or use? So let's get on with today's episode. This one's about the agent authorization boundary. So let me kind of define what that is, and I'll try to be relatively simple because I want to give Davis an opportunity to explain some of the real world impacts here. But anyway, agent authorization answers a really simple question. Given an identity of an agent, how do we attribute permissions, capabilities about what it can actually do? So here's the challenge. In today's world, if we look at the employee model, employees participate in business processes, just like our proposition of agents participating in business models. Employees have standing permissions. In fact, they may have standing elevated permissions to do real work. The traditional model would say that why don't we treat agents just like people or employees and give agents standing permissions? That's a problem. It's actually a problem by design. Where we can actually be comfortable in an employee's accountability, we can't necessarily have that same level of comfort with agent accountability. So we need to actually design the authorization boundary much, much differently. It needs to be narrow by design. It needs to be specific to a particular task at a particular time for that specific agent. So what happens when that does not occur? Davis, I know you've done a little bit of research here, but give us some examples of agents going wild or agents going rogue. I know there's a few out there.
Oh, there are definitely more than a few examples out there, but there are a few I want to focus on. The first is an incident that happened with a company called Pocket OS, where the founder was using AI agents, specifically one involving a Claude model, in order to do work involving the company's code base and database. And of course, because I'm talking about it now, you can realize there was a problem here. Namely, when he was working with the AI and watching it do some of its work, the AI decided that it was going to, rather than make the change requested, the easiest way to accomplish it was to delete and attempt to recreate the production database. And because it was being used by the CEO of the company, it had the permissions to do this. And so Pocket OS ended up having their entire production database and the backups of that database completely deleted. The disruption to service was immense. They had to reconstruct their entire environment from a 3-month-old offsite backup, as well as going to their client and business partners and requesting data from them so that they could reconstruct their own records. Suffice to say, this was not a good time for the company, and there were a great many outraged calls from the customers. But the thing is, you can't attribute this to the agent not understanding the rules it was given. When this happened, the founder asked the agent, "Hey, why are you doing this? There are explicit rules." And the agent was able to list exactly what rules were in place to prevent it from doing this, and was able to explain that yes, it had in fact broken these rules. So you can't simply rely on telling the agent what rules it has and expecting that to hold in every case indefinitely, because the agent can understand the rules and still get confused and do the wrong thing for immense damage if it has access to the right permission structure.
Wow. So truly an example of agents going wild. Now, there's another example. I believe it's Amazon, Davis. Why don't you tell us about that one?
This one was a problem with, I believe, an agent Amazon decided to call Kiro, and it involved kind of a similar mess up, where the Kiro agent was attempting to implement a fix and decided that the best way to implement this fix was to take down, delete, and recreate a production environment. And because it was being worked on with a senior engineer at the time, it had permissions that it ordinarily would not have, which let it actually do this. And of course, this resulted in a 13-hour service outage of AWS itself, which is the sort of thing that has a pretty big business impact and is going to get noticed. And once again, it comes back to the agent had the same permissions as the senior engineer it was working from. And while any senior engineer can probably realize that this isn't actually something you should be doing, AI agents don't necessarily think things through in the same way that a person would.
And they definitely don't have the same accountability. But I want to kind of elevate this now to a little bit of a discussion around the architecture and the solution to some of this. So, Davis, there's really two general types of agents. There's what we call coding or personal agents. Examples are like Claude Code or Codex. And these things operate on your own machine or your environment, and they inherit permissions from you, just like the Pocket OS example. Whoever is using these agents, that's the permission that those agents inherit, and they are able to access your environment. They're able to do roughly the same things that you can do, and they may even have access to some of your secrets. We're going to hold off on discussing how to solve the coding agent problem, and instead, we're going to start with what we call enterprise agents. And try and explain how we solve the problem for enterprise agents. Now, enterprise agents are those agents that participate as full actors in a business process. They are doing real work. They're headless, and they have their own identity, and they have their own permissions. Now, there's still a challenge around that in the sense that how do you ensure that those agents have the right permissions for that particular task at that particular time? So we're going to talk a little bit about that architecture. So, in our experience, there's probably 5 to 6 components that need to interact. And I'll go through them relatively quickly, and then we'll talk about how these things actually work. So clearly a request comes in, and in enterprise agents, the form factor for agent collaboration in the ecosystem is the business process. So the request comes in, and it gets intercepted and addressed by a process orchestrator. What the orchestrator does is it maps that business request to a particular business process, identifies the tasks associated with that, and then based off of that task, it selects an agent based on the requirements of that task, and it looks at that task, which defines the skills and the tools that are allowed to actually participate in that task. What does it do with that? We go to what we call a trust authority. The trust authority is the policy decision point in the grant issuer. It asks itself, given this particular task definition, which agent would be most suitable for that? And given the tools and the skills, it creates a grant that says this agent that I've just identified can execute these tools for this particular task and only this particular task, or for a very brief time period. And it creates a grant. Those grants are given to the agent. Now, at runtime, what it does is it actually looks at that, says, hey, now I know what I need to do. I have the task information and the scope of work. I'm going to now try and execute that work using the skill and the tool that I have. It actually will use the grants, which define the tools and the skills I can use, and it will actually go to try and execute those. It's going to go to a tool executor or a skill service with that grant, and that grant is going to be validated at runtime. If the grant is valid and it hasn't expired, or it's a one-time and that one-time execution has not yet occurred, it will actually execute the tool. Now, that's the process that we believe are table stakes in today's secure environment that's required for agent execution. And if we have these capabilities, our belief is that we're not going to have the things that you saw at Amazon or the Pocket OS, because we will be able to govern what the agent can do at a very specific and granular level. So, Davis, tell us what this grant actually looks like and why is it important?
So a grant is basically a key or certificate signed by the trust authority that says this agent is allowed to use these tools for this amount of time or for this one-time use case, and it's designed to effectively get permissions down to the point where you don't have to give a blanket permission to an agent, because doing that has all sorts of dangers associated with it. So instead, you give this grant, and the agent then can go and use its tools, use its skills for the moment it needs them. And then once it's done with the task, once it's done with the execution, the grant can go away. It expires, and the agent can no longer do those things unless it's given a new grant. And this keeps permissions very isolated. So instead of needing to have a set of database permissions for this database and this other database, because at some point somebody might need to use the agent to access them, or just giving it a broad user credential that can access all sorts of systems, you instead can lock these credentials behind effectively these grants, so that if an agent needs to access a particular database, it can only access that database for the duration of the task. This means it can't, say, target queries from one database to another. It can't go and do things it doesn't have permissions for. You can even restrict these permissions to specific operations, so that, for instance, if you're retrieving data from a database, you don't have to give the agent an account that has permissions to, say, delete things from a database. And this effectively, gives us the fine-grained permissions you need.
Perfect. So what you're saying, to paraphrase, is the task definition is the bucket that says this is what not only what needs to be done, but what tools and skills are permitted to actually execute that. The grant is based off of the information in that task definition through the task authority. It says that this particular agent is allowed to do this particular set of work at within this particular set of time frame, or a one-shot deal, and it carries effectively it's a claim. It's not actually containing any secrets. So what that means is that the grant needs to be validated at runtime. Now, I think the other thing we should probably highlight is these grants obviously enable an agent to do real work, and if this real work has elevated permissions, we need to be actually very, very careful that this grant cannot be tampered with. So these grants, Davis, are they cryptographically signed?
Of course they would be. Like, there's no point in giving a grant that isn't cryptographically signed. Anyone could just forge their own.
So what that really means is if these grants are cryptographically signed, we can say confidently that when the agent gets it and they can check that cryptographic signature, that we can be confident that the agent got a grant that was not tampered with, and hence it is valid. Now, I want to contrast the grants with what's popular with OAuth 2. And with, maybe not necessarily OAuth 2, but when you look at an employee, you have roles and permissions, and those are standing permissions. Those are things that, when I say standing, they don't change very frequently. An employee may have change their job description, may move to a different part of the organization. At that point, that role would change. So effectively, if we use the employee model, it starts to break down here. As you can see, having standing privileges is problematic. So now here's the challenge: is why not use some technology that we already know, say OAuth 2, with bearer tokens, and actually use those as instead of these grants? Well, here's the problem: is the OAuth 2 bearer tokens have something in them called a scope, and those scopes are typically assigned based off of an identity, and they typically follow a model where those that identity and the roles and permissions associated with that identity are effectively standing capabilities. They are long-lived, and that means that capability is around for a very, very long time, not for the duration of a particular task, but for a long period of time. If we give that capability to an agent, what we have is standing permissions, elevated permissions for an agent. And if we retain that, we are back to the same situation where we have agents having potentially inherited permissions, but long-running permissions that span well beyond the task. And unless the tasks are specifically or very well defined, those permissions can actually leak. Now, I want to talk a little bit about the next obvious question that somebody's going to ask. So I get now why OAuth 2 may not necessarily be the perfect thing. Of course, OAuth 2 has a real role and is fantastic at conveying in the bearer token things like they can be confirming the identity of the actor, in our case, an agent. But why not use MCP? MCP being Model Context Protocol from Anthropic. And we think that's we're big fans of MCP, but we also know their limitations. Simply put, MCP does not actually define the authorization boundary. It is very much predicated on OAuth 2, which means there is a significant chance for standing elevated permissions. We believe that opens a very significant security hole, and that is inappropriate. We believe strongly that the permissions given an agent need to be specific to a particular task that is being done for a particular very short period of time, or it's a one-off, and it needs to expire or go away after the actual grant has been executed. So that's one of the reasons why we think MCP is not sufficient. But the grant capability also offers another benefit. So Davis, obviously, if we can capture these grants, we generate them, we can capture them, we can see when they're executed. Does that provide a foundation, an audit foundation for a variety of other capabilities?
Of course. Like, this system very easily and obviously ties into whatever auditing and logging systems you're going to have. Like, unlike the current paradigm of coding agents where these logs really only exist, if they exist at all, on a host machine, you're going to have very fine-grained logging and tie these into the grant system. Every time a grant is issued, that is logged in the trust authority. Every time a grant is used, that'll be logged via the tool executor, which we're going to discuss more next week. And this gives you a lot of potential use cases for this. You know the grant, you know when the grant was issued, you know when the grant was used, you know when the grant expired. And this gives you a lot of things you can do with it. You have audit records. You can fulfill legal requirements if you need to track very specific things that are going to happen. You can use this for debugging to figure out exactly the sequence of operations that was going on if something went wrong, to do sort of a recovery or analysis. You can do statistical analysis on exactly what tools are being used. And if you tie this into a system that tracks token usage, you can also do analysis on that as well and see how many tokens did the agent use before it delegated to this tool or how many did he use after this. Try and get a sense of how efficiently tokens are being used through various operations. And this as a whole gives you a lot of information that you can use in order to get a better understanding of what your agents are actually doing when they're doing their work.
Perfect. Now, I want to transition to coding agents because everything we've talked about are enterprise agents, these headless or ambient agents that are not attached to a user ID, that are running in business processes. And I think what we've done is we've clearly demonstrated or highlighted an architecture focused on grants, very, very short-lived permission capabilities that define what an agent can do over what period of time, etc. Now, enterprise agents are different than coding agents, but we think the same principle applies. Now, I want to take a quick step back because at the preamble, Davis gave two excellent, unfortunately excellent examples of where agents have gone rogue and do the wrong thing. These effectively were coding agents. As Davis mentioned, these are agents that inherited the permissions from the people running them. In this case, it was a senior engineer for Amazon. It was a very senior executive for Pocket OS. So the implications are tremendous. And I know in our discussions with security professionals, the ability for an agent to have bash access, internet access, and even extended permissions. I think everybody's used Claude Code or Codex. When it asks for the ability to do something, it says yes once, yes forever, and then something like no, don't do it. The temptation is to say yes forever, because after you've done it a few times, you realize that we're not going to get the speed or efficiency gains unless we actually streamline the process. So the tendency is to give increasing levels of capability permissions to the coding agents. So the challenge now is, can our architecture apply to coding agents? Davis, where's your head at?
The architecture can apply and a lot of the same principles can be used, but they need to be extended and changed in order to deal with the breadth of behavior that a coding agent needs to do. Unlike an agent, a business process, you don't have a well-defined task that you can easily assign a limited list of skills and tools. Instead, we're going to have to go back to roles. Effectively, instead of giving an agent access to the entirety of a developer's credentials and machine, we keep it to a more limited subset of functionality. You don't actually need an unrestricted bash tool, for instance, that is capable of performing literally any operation the computer is capable of. Instead, what you actually need is a much smaller subset of tools. You need a tool to do an ls. You need a tool to do a change directory command. You need a tool to read a file. But these don't all have to be through the same bash tool. A collection of much more specialized tools that have much less ability to go wrong will allow the developer to still do most of the things they're currently doing with considerably less risk. So what it comes down to is there's going to be standard profiles in a business that effectively say, these are the list of tools you are going to come with. This is the sort of remote file system you're going to be doing your work on, so that there is a limit to how much damage these things can do by default. And then if a developer needs access to a specific tool or specific database beyond these, they can go and request approval from someone higher up in the system and get an exception added, get an additional tool added to their system for the duration of, say, their project or some other managed amount of time that is smaller than just giving it forever, and without giving the full access to the developer's permission to this coding agent. Now, these specific profiles are going to be different for different jobs. A developer, a knowledge worker, a database engineer are all likely going to have different profiles with different default sets of tools included that help them better accomplish their role.
Perfect. So I want to now talk a little bit about the knowledge worker that I think you mentioned. I want to give you an example. I was listening actually to the Twiml AI podcast, quite popular. They gave a great example. So this is not my example, but I think you can probably relate to this relatively easy. So this is a situation where I have I'll call it a personal agent for a knowledge worker as opposed to coding agent. I don't know if every knowledge worker is a coder. So let's just call it a personal agent, Claude Code, just to be very specific, still, or Codex. Suppose as a result of your job, you need to look at Salesforce information. Some of that stuff is very, very sensitive. It's about customers, may even have some privacy regulations attached to it. So to do your job, you ask the agent to help you with Salesforce. However, completely distinct from that, your job also has a simple requirement of communicating with other people. You use Gmail, for example, or your corporate email, but Gmail is very, very common for mid to smaller size companies. Now imagine if that agent can actually get that information from Salesforce and unintentionally also access Gmail and send out information, unintended information that you normally as a person probably wouldn't, but it doesn't have the same judgment necessarily as you, but it finds that it actually has information about customers that may be useful for a marketing campaign. And it then issues a Gmail request for that marketing campaign. And all of a sudden what you have is you have, despite the best efforts of separating the access from Salesforce and the need to use Gmail, a person can understand the difference between the two. But an agent, as Davis mentioned, may go upon itself to actually try and do some things. And what we have is an opportunity for data leakage, potentially sensitive data leakage. That is a big problem. So Davis, when you think about the knowledge worker, how does this architecture that we've been talking about apply to a knowledge worker?
This applies to a knowledge worker in the sense that you need to make sure that the profile that a knowledge worker has, their personal agent, the tools they have access to, don't permit this sort of leakage. For example, while a standard coding agent, if you give it the right permissions, might be able to access both, you can easily just say, no, you're not allowed to access Gmail. The Gmail tool isn't available. You're not allowed tools that, for instance, access the ability to send data externally at the same time as you have access to our databases. You're either doing one thing or you're doing the other, and you're not doing both simultaneously. And it is perfectly acceptable to have a policy that says, yes, you're allowed to access these sensitive databases, but if you need to write an email, you're going to have to either do that personally or do it on that other agent over here that doesn't have access to the first agent's information, and use the person and their judgment as a go-between.
So what we're saying is the knowledge worker has the same dilemma, the same security gaps that the coding agent, the user using the coding agent, but instead of the local repository of code on the machine, we're talking about information that resides in databases, sensitive information in databases. So effectively, what we're saying is that the ability to structure grants and to separate and segregate the agents and their capability allows you to plug that gap. And I think that's fundamental to moving forward. So what that really means, though, is a different architecture. It means being able to structure what the knowledge worker or the coding or the developer using the coding agent does, but put it behind a security barrier so that it can be governed, managed, audited as necessary, so we can safeguard not just what the developer can do, but safeguard the information that a knowledge worker can actually access. Did I get that right, Davis?
Yes, I think you've got the understanding of how all this ties together.
Okay, perfect. So now I'm going to wrap up, Davis, we've talked about in the previous episode identity, and in this episode, we've identified how that identity can be used to attribute who the agent was that actually did the work. But we can now actually constrain that agent to a specific set of skills and a specific set of tools through this notion of grants that limit the authorization boundary very clearly. Next week, in our next episode, we're going to talk about how we actually enforce those grants. What's the information flow that lets these grants actually be enforced to guarantee that inadvertent tool execution does not occur, or inadvertent use of skills, which may be proprietary, intellectual property, are not shared beyond the boundary as appropriate. So that's in the next episode. So on behalf of Davis and myself, thank you for listening. Hope you enjoyed it, and we hope to have you back for next week.
See you then.
Bye now.